Hi everybody, Mrs. Bowen here, and we're going to take a look at guided notes for standard 25 distance. For our warm-up, we are asked to plot and label the following 3 points. So for point A, I need to put a point at 2, 7, or this means x is 2 and y is 7. So 2, 7, that's my point A. My point B is at 2, 3. And my point C is at the point 5, 3. So I have 3 points. And then I have to find the length of each side of the triangle. So these 3 points here are forming a triangle. So I can connect them. So there's my triangle. And I need to find the length of each side. So my first side length that I'm finding is AB. And AB is right here. So I can simply count the number of units. Side AB here is going vertically, so I can count that it's 1, 2, 3, 4 units. Next I have side BC, and BC here is going along the bottom of my triangle. It's going horizontally, so I can simply count the units. It is 1, 2, 3 units. And then my last side of the triangle, AC, this side is going diagonally, and so this means I can't just count the number of units because side AC is diagonal. So I need to come up with another way to find the length of AC, and this is a right triangle, so we couldn't put a square tick mark here. And if we recall from all of our work with the Pythagorean theorem and its applications, we learned that the two sides that form the right angle are the legs, and then the longest side across from the right angle is the hypotenuse. And we learned the Pythagorean theorem, which says a squared plus b squared equals c squared. And we can use this knowledge of the Pythagorean theorem to help us find this diagonal side, which is our hypotenuse or our c. So for A and B, I'll plug in my 2 legs, and it doesn't matter which leg I say is A and which leg I say is B. My 2 leg side lengths were the 4 and the 3. So I'm doing 4 squared plus 3 squared equals my hypotenuse squared. That's what we're trying to find. 4 squared is 16. 3 squared is 9. Or I could have quickly done this whole piece in my calculator. I'll get 25 equals c squared. But I'm looking for just c, just my hypotenuse. So to undo something squared or something raised to the second power, I have to take the square root of both sides, and then I'll get c. My hypotenuse is 5. So by using this vertical distance and the horizontal distance, I knew my leg side lengths, which helped me to find my hypotenuse, which was my diagonal side length. Let's look at another example. So example A says to find the length of each segment. And notice here I have a segment and it's going diagonally. So I can't just count the number of units. What I can do is use my knowledge of Pythagorean theorem. So I can create a right triangle by drawing 2 legs, and then the length that I need to find here, I could call it X, I could call it C, I could put D for distance, I could put question mark there, but my unknown is this diagonal length. That's what I have to find. So one of my legs here is going vertically, and it's 1, 2, 3, 4, 5, 6 units. So one of my legs is 6, so I'll have 6 squared plus. My other leg is 1, 2, 3, 4 units. So I'll have 6 squared plus 4 squared equals my unknown diagonal length, x squared. And then I can quickly do this in my calculator, 6 squared plus 4 squared, and I'll get 52 equals x squared. To undo x squared, I need to take the square root of both sides, and then I'll get that x equals 7.2. So my diagonal length of this segment x is 7.2 units. So now when you tries 1 and 2, you have 2 other diagonal segments. I'd like for you to give these a try. Go ahead and pause the video. Let's see how you did. In you try one, I found that my two legs were 6 and 8. So I was doing 6 squared plus 8 squared was equal to my diagonal length of the segment, and I got that that length of the segment was 10 units. In you try two, my legs were 3 and 7, and I ended up finding that the length of my diagonal segment there was 7.6 units. Let's try a few more examples. So when I get to example B, the directions say to find the distance between each pair of points. So now you're not given a segment, instead you're given the ordered pairs, and you need to go ahead and plot those points. So the first point I'm plotting is 3, 8. So I need to go where X is 3 and Y is 8. I need to put a point. And then the other point I need to plot is -3, -2. So X is -3, Y is -2. So I plotted my 2 points, and I'm trying to find this distance between them. That's what I'm trying to find, that distance. I could label it as D. And I can again use my knowledge of Pythagorean theorem to create a right triangle here. That will help me. And so then I can count my leg lengths, because again, my legs of the triangle are going horizontally and vertically. So my horizontal distance here when I count is 6 units. So I'll be doing 6 squared plus my other leg squared here when I count is 10 units. So plus 10 squared equals, and in this case, I'm just using the variable D for that distance that we're trying to find. When I do 6 squared plus 10 squared, I get 136 equals my distance squared. Take the square root of both sides, and I get that my distance is 11.7 units. There's another way that you could have found this diagonal distance here between these 2 points without drawing the right triangle. I could also look at just my X values, so the 3 and the -3, and I can look for how many units did it change. So if you just think of like a number line with 3 and -3, I changed 6 units, so that leg will be 6. And then if I look at my Y values, and now I'm thinking here of the vertical change, how many units did it change? If it went from 8 to -2, well, it changed 10 units. So if you can visualize the difference here between your X values and your Y values to get your legs, you can do that. But be very careful, especially when you have some negative signs here. You're looking at like the absolute value in distance, or think of a number line, and you're counting the number of units that X changed to get one leg, and then for the other leg, the number of units that Y changed. A foolproof way is to always draw the triangle and then count your units that way. So on example C, I've got 2 more points to plot. So 0, 3 is 1 point, and then my other point is at 2, 1. So X is 2, Y is 1. So this is a very short distance, but I still can't count the number of units because it is diagonal. So I'll label that as D. And I need to create my right triangle. It's a very teeny right triangle. And actually both of these legs end up being 2 units. So I'm doing 2 squared plus 2 squared equals my distance squared. That gives me 8 equals my distance squared. Last step, take the square root of both sides, and I get that my distance equals 2.8 units. And then our last example, example D, first ordered pair is 4, -2. So X is 4, Y is -2. And then my other point is at 0, 5. So X is 0, Y is up at 5. So there are my 2 points. I'm trying to find the distance between these 2 points. So I can create my right triangle and use the leg lengths here to help me find this diagonal distance. So one leg here is 7. So I'll have 7 squared plus my other leg is 4. That's 4 squared equals my distance squared. I'll get 65 equals my distance squared. So my distance is 8.1 units. I could have also looked at just my change in my X values here and thought, how much did X change if it went from 4 to 0? Well, it changed 4 units. So one of my legs is 4. And then for my Y's, if I was at -2 and I went to 5, that's 7 units change. And so my change, my vertical change, or for my value for my other leg, would be 7. So you can, again, look at the ordered pairs, or you can always draw the triangle to help you. All right, if we flip to the back side, you have U-tries 3 through 6 to do. So for 3 through 5, you're finding the distance between each pair of points like we just did. And then when you get to U-try 6, similar to what we've been doing, but it's a little bit of a story problem. So go ahead, pause the video and see what you come up with. On U-try 3, you could have drawn your triangle and looked at the 2 different leg side lengths and use that to help you to find this horizontal distance between the 2 points. Or you could have looked at your change in X, or your horizontal change, which here was 2, and then looked at your change in Y, or your vertical change, which here was 11. And I got a distance of 11.2 units. On U-try 4, my horizontal change was 5. My vertical change was 12, and so I got a distance of 13 units. And on U-try 5, my horizontal change was 6, my vertical change was 9, and I got a distance of 10.8 units. U-try 6 says, while training for a marathon, you decide to run from your home at H, through the park to C, along the road to D, then straight back home. How far will you run? And so I'm hoping you were realizing that you could quickly draw a right triangle. You could use your legs using your Pythagorean theorem, and we would find that this diagonal distance here is 12 units. Be very careful that your final answer isn't that this diagonal distance is 12 units. It was asking, how far will you run? So keep in mind, you're running this whole distance. You're basically running a big triangle. And so you found that this diagonal distance is 12, and then you run 8 units, and then you run 9 units. So you're doing 12 plus 8 plus 9. So your answer is that you will run about 29 units.